So hello everyone, my name is Navaganesh M. Badmanathan and I am a research assistant at the Southeast Asia Disaster Prevention Research Initiative based at the National University of Malaysia and simultaneously working on the water sector transformation study, 2040, by the Academy of Science Malaysia. So my presentation today is going to highlight on the Miri Hill structure that is formed by the normal faulting at the releasing band geometry of strike slip faulting. So I'll move on to the introduction. As we all know, Borneo Island is part of Southeast Asia, and it is caged by this Philippine sea plate from the east and Indo-Australian plate from south to southeast direction. And we all know that Borneo is actually oriented in a northeast southwest, in contrast to the western portion of the Sunda plate, which is northwest southeast. It is generally believed that Borneo Island has undergone a counterclockwise rotation since Mesozoic, and some researchers believe that it is still ongoing. However, our focus today is going to be on the northwestern portion of Borneo Island, particularly on the Miri Hill. Miri Hill belongs to northern Sarawak, and Sarawak is the biggest state in Malaysia. And why we chose this hill is because it was previously interpreted as a simple anticlinal ridge, but later works have demonstrated that this faulting mechanism has played a key role in the formation of this structurally high in an otherwise flat region. It has been reported by several researchers, for example, Sandel 1996, Hutchinson in 2005. They have shown that there is a number of fault along this region. And our motivation for this study is to improve what is geologically known and unknown, and refine the mapping work in Miri, at the Miri Hill. So before we get a better understanding on the results and the discussion section, here's the geological setting. So we all know that Miri Hill belongs to Miri Formation. So it can be classified into Upper Miri Formation and Lower Miri Formation. And the difference between Upper and Miri Formation is its deposit. Upper Miri Formation has arenaceous deposit, which is more sandy, and Lower Miri Formation is argillaceous deposit, which is more shaly. And the depositional environment is more to shallow marine environment. But Hutchinson has proposed a much more precise environment for this for Miri Formation, which is the littoral non-marine to inner neritic shallow marine environment. And apart from depositional environment, we must know that there are a number of faults which have been mapped which we can see from the previous work. So there are three major fault, I would say, that happens to be controlling this deformation according to the previous works. So the most famous one is the Shell Hill fault, which is a normal fault, and And then we have this Canada Hill Truss, which is and Kawang Truss. So these three fault are an important fault and has been studied by many researchers and also oil companies that were operating within this proximity. So I'll move on to our results. So Miri Hill is obviously not a typical anticline structure where both the limbs are observable and could be mapped for the entire extent of the structure. However, through our field investigation, it is an obvious indication that Miri Hill structure has a change of orientation from the southwest portion. We have structures that are steeply dipping more than 60 degrees and gently dipping northwest limbs about 16 degrees. There are changes. So these limbs do not show continuity of the structure, and at the northeast of the portion, the Miri Hill structure sees a dip direction change, a dramatic change from being from southeast to northeast, from steep to shallow, just within a very close proximity. You see there's a change there. And these similar changes are in fact observed in the northwest extent of this structure. And we believe that there must be, the changes does reflect the occurrences of a major structure. So in our discussion section, we have shown what are these faults. And in our discussion here, we have, as I've said earlier, we have came to an understanding that it is not a typical anticline structure, and instead we propose that there is some amount of influence from the major regional sinistral strike slip fault system that was mapped by Shah et al. In 2018. What is this sinistral strike slip fault? This is a major strike slip fault that we have mapped earlier, and what we came to an understanding is that it is a huge fault system that extends for more than 900 kilometers long, and it extends from south of Borneo to all the way of north. And we believe that some of the local seismicity are due to this particular fault. And Miri Hill is actually located on the northern Sarawak at the near to offshore region. But however, we believe that this hill is located at the releasing band geometry of the fault, because this regional fault, the regional strike slip fault, we believe that it has an oblique setting, can be attributed to this because of the simple shear mechanism. So this Miri Hill is indeed part of this simple shear mechanism that formed this strike slip system. So that is why you can see that whenever you have this system, it's going to be like you'll see compression and extension at one end. So what we have observed is that the structural orientation of this normal and reverse fault have formed simultaneously, which means that the extension and compressional structure have formed at the same time. What does this indicate? It indicates that there must be some amount of strike slip influence. So this is in a regional scale, but in a local scale, when we focus at Miri, so the compressional and the extensional direction of all this structure indicates that this heel is indeed has formed under the influence of a left lateral strike slip system. So this left lateral strike slip system that controls the deformation in Miri Hill is indeed one of a subsidiary fractures that came from this simple shear mechanism. So it is a very important system. And the most important the most important question is that, does this region generate seismicity? Well, at present times, there is a number of local earthquakes around this region, which is in a 100-kilometer proximity. So it is quite near. So what we can tell you is that if there is a major fault reactivation within this region, maybe we might expect something. Maybe we might expect some amount of seismicity here, but this scenario is unlikely, because if you look in a regional perspective, the most seismically active region in Borneo is in the northern region, North Borneo, particularly the state of Sabah, which belongs to Malaysia. So this region is the most active region. I mean, it is obviously being impacted from the far-field stresses. I mean, there is some amount of plate boundary forces. But in the case of Sarawak, we are looking at all this local seismicity that is generated due to all this local movements. So finally, what I would like to say is that this mapped structures, this mapped structural configuration of this fault, fold, and bedding is obviously consistent with a releasing band geometry, and it is has some amount of linkages to the major sinistral seismic system, and could have formed together during the progressive deformation in the region. And from our field investigation, it is revealed that some of the important faults here, for example, like as I've said before, this region has three main important faults: Shell Hill Fault, Canada Hill, and Kawang Thrust. So if you observe this figure A here, you know that Kawang has outer Kawang and inner Kawang Thrust. From our field investigation, unfortunately, we did not find this Kawang Thrust. This is because it came to our understanding is that this Kawang Thrust are mostly spotted at the subsurface depth. So that is the reason why we did not find any information. It is obvious in the seismic survey carried out by all these oil companies. They were working there and they did quite an amount of work there. Our field investigation revealed many information because the rapid development in this region exposed many outcrops, and from all this information from field investigation, we have concluded that it is not a simple anticline, and in fact a very complex region where you can see the influence of strike slips. And here are the references I've used for this presentation. There are more references in my research paper, but for this presentation, we have just used three: Hutchinson, Sandel, and Shah. And with this, I would like to end my presentation, and have a great day ahead. And please let me know if you have any doubt on the presentations.